Article 680 Section 680.22 of the National Electrical Code addresses ground fault circuit interrupter, or GFCI, protection for receptacles. Specifically, it mandates that all 120 volts and 240 volts single-phase 15 amps and 20 amps receptacles installed outdoors and in certain other locations must be protected by a GFCI. There are exceptions to this rule. Firstly, the requirement does not apply to receptacles installed in industrial establishments. Secondly, receptacles that are not part of a permanently installed swimming pool, spa, or similar installation are also exempt. The 20 amps limit for GFCI requirements in Article 680 exists primarily because GFCIs are not readily available for higher amperage ratings. In the described scenario, the 7.5 horsepower motor powering the SwimX is likely to draw more than 20 amps. Therefore, according to this specific section of the code, a GFCI is not explicitly required for this particular circuit. However, it is important to understand that Article 680 does not prohibit the use of GFCIs on circuits that are not mandated to have them. In some cases, local jurisdictions may have stricter regulations, potentially requiring GFCIs to be installed on all outdoor circuits, irrespective of their amperage rating. Furthermore, the National Electrical Code mandates GFCI protection for all swimming pools and spas. This requirement is found in Article 680.26, which is a separate section from the GFCI requirement outlined in Article 680.22a. To summarize, based on the information provided, a GFCI is not explicitly required for the 7.5 horsepower motor powering the SwimX in the basement. However, to ensure compliance and safety, checking local electrical codes to determine if there are any additional GFCI requirements for outdoor circuits is necessary. The requirements outlined in the National Electrical Code are aimed at enhancing safety. By limiting the GFCI requirements to 20 amps and below, the code targets the circuits where ground faults pose the greatest risk. Ground faults occur when electricity flows outside its intended path, often through a person or conductive material, creating a shock hazard. GFCIs are designed to detect these ground faults and quickly interrupt the circuit, minimizing the risk of electrical shock. For higher amperage circuits, other safety measures are typically employed, such as grounding and bonding, which provide a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse. Understanding the nuances of the National Electrical Code and local amendments is crucial for electrical professionals and homeowners alike. Consulting with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations is always recommended. The availability of GFCIs for various amperage ratings is also a factor in the code's requirement. While GFCIs are readily available for 15 amps and 20 amp circuits, finding them for higher amperages can be challenging. This limited availability is due to the increased complexity and cost associated with manufacturing GFCIs that can handle higher currents. As technology advances, the availability of higher amperage GFCIs may increase, potentially leading to changes in the code requirements in the future. The National Electrical Code is a living document, constantly evolving to reflect new technologies, safety concerns, and best practices. Regular updates are issued to address emerging issues and improve electrical safety. Staying informed about the latest code revisions is essential for electrical professionals to ensure that their work meets the current standards. In addition to GFCI protection, other safety measures are crucial for swimming pools, spas, and similar installations. These measures include proper bonding of all metallic parts, such as the pool structure, pumps, and lighting fixtures, to create an equipotential plane that minimizes voltage gradients and reduces the risk of shock. Bonding involves connecting all metallic parts together with a continuous conductor, ensuring that they are at the same electrical potential. This equipotential plane helps to prevent dangerous voltage differences from developing between different metallic parts, which could create a shock hazard for swimmers. Furthermore, proper grounding of the electrical system is essential to provide a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse. Grounding involves connecting the electrical system to the earth, providing a reference point for voltage and helping to stabilize the system. The combination of GFCI protection, bonding, and grounding creates a comprehensive safety system that minimizes the risk of electrical shock in and around swimming pools, spas, and similar installations. Regular inspections and maintenance of these safety systems are crucial to ensure their continued effectiveness. Any damaged or corroded components should be replaced promptly to maintain the integrity of the safety system. In the context of the SwimX motor, while a GFCI may not be explicitly required by the National Electrical Code, it may still be a worthwhile investment to enhance safety. A GFCI can provide an additional layer of protection against ground faults, which can occur due to various factors, such as damaged wiring, moisture, or insulation breakdown. Installing a GFCI on the SwimX motor circuit can help to minimize the risk of electrical shock and protect swimmers from potential hazards. The decision to install a GFCI on a circuit that is not required to have one is a matter of personal preference and risk assessment. Some individuals may choose to install GFCIs on all circuits, regardless of the code requirements, to provide the highest level of protection. Others may opt to follow the code requirements strictly and only install GFCIs where they are mandated. Ultimately, the choice is a personal one, but it is important to consider the potential benefits of GFCI protection and weigh them against the cost and inconvenience of installation. When considering the installation of a GFCI, it is important to select a device that is properly rated for the circuit. The GFCI should have an amperage rating that is equal to or greater than the circuit breaker or fuse protecting the circuit. It should also have a voltage rating that is compatible with the circuit voltage. Using a GFCI that is not properly rated can create a safety hazard. It is also important to follow the manufacturer's instructions carefully when installing a GFCI. Incorrect installation can render the GFCI ineffective and create a safety hazard. If unsure about the proper installation procedure, consulting with a qualified electrician is recommended. They can ensure that the GFCI is installed correctly and that it is functioning properly. Regular testing of GFCIs is also important to ensure that they are working correctly. GFCIs should be tested monthly by pressing the test button on the device. If the GFCI trips, it is functioning properly. If it does not trip, it may be defective and should be replaced. Testing GFCIs regularly can help to identify potential problems early and prevent electrical shocks. In addition to GFCI protection, other safety measures should be taken to minimize the risk of electrical shock around swimming pools, spas, and similar installations. These measures include keeping electrical appliances and cords away from the water, avoiding the use of electrical devices while wet, and never touching electrical equipment while in the water. Educating all users of the pool or spa about electrical safety is also important. They should be aware of the potential hazards and know how to respond in case of an emergency. Posting warning signs around the pool or spa can also help to remind users of the safety precautions. By following these safety measures, the risk of electrical shock can be significantly reduced. Electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents. By being aware of the potential hazards and taking appropriate precautions, we can create a safer environment for ourselves and others. The National Electrical Code is a valuable resource for electrical safety information. It provides detailed requirements for electrical installations and equipment aimed at minimizing the risk of electrical shock and fire. The NEC is updated regularly to reflect new technologies and safety concerns. Staying informed about the latest code revisions is essential for electrical professionals and homeowners alike. Consulting with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations is always recommended. The National Electrical Code is not the only source of electrical safety information. Many other organizations, such as the Electrical Safety Foundation International, offer resources and training on electrical safety topics. These resources can help to educate people about electrical hazards and how to prevent them. Electrical safety is a complex and multifaceted issue. There is no single solution that will eliminate all electrical hazards. However, by combining GFCI protection, bonding, grounding, and other safety measures, we can significantly reduce the risk of electrical shock and fire. Continuous education and awareness are key to promoting electrical safety and preventing accidents. By staying informed about the latest safety practices and taking appropriate precautions, we can create a safer environment for ourselves and others. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations.